Hello there, this is Ms. Nakayama again. Today's lesson is 12.3 Shapes of Distributions. So to continue with how we ended 12.2 box and whisker plots, we have, histograms as our distribution. Before we were talking about box and whisker, but we knew that a box and whisker plot was skewed left when the longer whisker was on the left. When you have a histogram, they refer to it as the tail being on the left. And if the tail is on the left, then most of the data are on the right. If the tail is on the right, most of the data is on the left. That's why the bars are higher. And of course, symmetric means it looks close to the same on both sides. So in this first example, the frequency table shows the number of raffle tickets sold by students in your grade. Display the data in a histogram. Describe the shape of the distribution. To speed it up, I went ahead and put, your handout has the histogram already on it. So when you look at that, can you tell me whether you need to think about whether it's skewed left, skewed right, or symmetric? And basically there, even though the bars aren't the same height, you still have the same amount of data on the left and the right. So we say that this distribution is symmetric. All right. Now, one of the important things about that is if your data is symmetric, then we use the mean and the standard deviation to describe its center and variation. If your data is skewed, then you use the median and to describe the center and the 5-number summary, our box plot type thing, to describe the variation. So that's the key, knowing what the data looks like as to which measure you're going to use to describe the center and the variation. So look at example 2 here. A police officer measures the speeds in miles per hour of 30 motorists. The results are shown in the table at the left. Display the data in histogram using 6 intervals beginning with 31 to 35. So you would go and make these intervals, and then you would go put these in the appropriate category. Again, speeding it up, the frequency is already there. You take that frequency table and put it into a histogram. So it's pretty easy to do in Elta Math, and I'm sure y'all won't have any trouble with it. Part B says, which measures of center and variation best represent the data? So when you look at that data, I hope that you can see, that there is a tail over here on the left. So because there's a tail on the left, my data is skewed left, and therefore I'm going to use the 5-number summary to describe the data, the median for the center and the 5-number summary to describe the data. The speed limit is 45 miles per hour. How would you interpret the results? Well, if the speed limit's 45 miles per hour, which is right here, then I think we can assume that most of the motorists were speeding. Not a good thing, but that's what our data tells us. All right, look at example 3. Emoticons, those lovely things right there. Emoticons are graphic symbols that represent facial expressions. They are used to convey a person's mood in a text message. The double histogram shows the distributions of emoticon messages sent by a group of female students and a group of male students during 1 week. Compare the distributions using their shapes and appropriate measures of center and variation. So to talk about the shape of the distribution, the female students, I hope y'all can tell, that looks basically symmetric. However, the male, most of the data is on the left, so we say that it is skewed right. So that's how the female is symmetric, the male skewed right. That's their shape. Now, to talk about the appropriate measures of center and variation, remember if it's symmetric, that we're going to use, if it's symmetric, we use the mean. We'll just set it up here. We use the mean and the standard deviation, and if it is skewed, then we're going to use the 5-number summary. Okay, that was a short pause. So as I was saying, the female students have a symmetric distribution. The male students have a skewed. So when I'm trying to talk about their center and their variation, the symmetric, I'm going to use the mean. So the mean of the female data is probably in this 30 to 39 interval, but the median of the male data is probably in this 10 to 19 interval. So that's where the centers are different. And because of that, the typical female student is much more likely to use emoticons than a typical male student. I know you're shocked by that information. And then to talk about the variation, okay, that would be for standard deviation, if it's symmetric, okay, it's spread out more, but it's spread out more than the males, and we would use the range. But again, hard to compare those two since they're different actual ways of measuring that. But you can see from the data that the female students spread out more than the male. Therefore, the use of emoticons tends to differ more from one female to the next. Okay, so let's look at comparing data distributions in box plots. So make a double box and whisker plot. Again, I already did it to speed things up. And describe the shape of each distribution. All you're given is, this was the information to actually make the box plot, but I know you already know how to do that. So we're going to go on to describe the distribution, okay, looking at the women, okay, the whiskers are about the same on both sides. So we're going to say the women are symmetric and the men are longer whiskers on the right. So the men are skewed right. Part B says, compare the number of pairs of shoes owned by men to the number of pairs of shoes owned by women. Well, since the mean for women is twice, and that's looking up here, the mean for women is almost twice the median for the men. So this is because they're symmetric, we use the mean. Because theirs is skewed, we use the median, and that's twice. So there's more variability in the number of pairs of shoes for women than there is for men. Okay, this last question, part C, I'm going to come back to it because the book kind of assumes you know stuff that you don't know, so we got to throw it in there. Not really throw it in there, but we're going to make sure that you know what it is. So the law of large numbers, okay, will tell you that many real-life data sets have distributions that are bell-shaped. Have y'all ever heard of the bell-shaped curve? Okay, they're bell-shaped and approximately symmetric around the mean. This is called the normal distribution. You will study it more in depth in future courses, but for now you need to know the rules for this type of distribution and the standard deviations that go with it. We learned how to calculate that in 12.1. So I'm giving you a picture here. And these words are going to kind of describe what you see in that picture, but some people are visual and it just helps them to understand and remember. So remember this little symbol right here? I don't know if you've seen it, but you've seen sigma. Sigma was standard deviation that we did in the first lesson, but that little thing, that's a Greek letter mu. So this is saying mu plus a standard deviation minus a standard deviation plus 2 standard deviations minus 2. So what this distribution always is tells you that 68% of the data lie within 1 standard deviation of the mean. If I were to add, okay, then I've got 68% of the data there. I have 95% of the data within 2 standard deviations and 99.7% of the data within 3 standard deviations. Data values that are more than 3 standard deviations from the mean are considered very unusual. Now, because the data are symmetric, you can deduce that 34% of the data lie within 1 standard deviation below the mean, and 34% is 1 standard deviation above the mean. Similarly, if I go to the next one, okay, now this time, if I want to go to 2 standard deviations, I got to have both of these together. So if you add 34 and 13.5, you're going to get 47.5% of the data is within 2 standard deviations below it. 47.5 is within 2 standard deviations above it. And then last but not least, we have all 3 of them. So I've got a, half of it. So the other thing you can not really mention, but this is the mean. Half of the data is below it because remember, it's the median and it's the mean. The mean and the median are the same in a normal distribution. So that means half the data is over here and half the data is over there. Okay, but if I want to go between 3 standard deviations, I'm going to take half of 99.7, which is 49.85%, lie within 3 standard deviations below the mean, and 49.85% lie within 3 standard deviations above the mean. Okay, and last but not least, This is also known as the empirical rule or the 68, 95, 99.7 rule, which is helpful, if you want to call it that, to remember the percentage values that lie within an interval estimate in a normal distribution. Okay, so remember those, and we're going to come back up here to see. It says, about how many of the women surveyed would you expect to own between 10 and 18 pairs of shoes? So remember, our women were symmetric. So if they're symmetric, okay, then I can make a bell curve, okay, looking like this. And remember, okay, well, let's go. And so what was our mean? Our mean for women was 14 and our standard deviation is 4. So what this means is my mean is in the middle, that's 14. And if I add 4, I'm going to get to 18, add 4 again, and then subtract 4, and subtract 4. Okay, so we know that within that first interval between 10 and 18, I have 68% of the data. Between 6 and 22, I have 95% of the data. And between 2 and 26, I have 99.7. That's our empirical rule. Okay, the question is asking us, how many of the women surveyed would you expect to own between 10 and 18 pairs of shoes? So how many of the women between 10 and 18 right here? We know that's going to be 68%. So we have to assume the data is bell-shaped because it was symmetric. 68% of the females would own between 10 and 18 pairs of shoes. How many women do we have? We have a total of 40 women, so 68% of 40 women is going to be about 27 women. So that's the answer to the question. All right, one last problem. You'll have some of these in Delta Math. When Ariana goes bowling, her scores are normally distributed with a mean of 115 and a standard deviation of 11. Using the empirical rule, what percentage of the games that Ariana bowls does she score between 93 and 137? So I'm going to draw my bell curve, okay? And I'm going to know that my mean is in the middle here is at 115. My standard deviation is at 11. So I'm going to add 11, add 11, add 11, subtract 11, subtract 11, subtract 11. And they're asking us what percentage is between 93 and 137. And y'all, if you don't see 93 and 137 when you do this, you've added or subtracted wrong, because you're not going to get a question that these numbers aren't going to show up on your chart. So I'm looking between 93 and 137. That's that second one. So my answer is 95%. So that is the end of Shapes of Distributions. Thank you so much for watching, and y'all have a great day.